In a system of two linear equations, the lines represented by each equation have the same slope. Part B, explain why you chose your answers in Part A. If you recall, Part A said if the system of two linear equations, the lines represented by each equation, again, they have the same slope. Part A was asking which could be the total number of solutions to the system of equations. For Part A, we found out the answer was that there could be no solutions or infinitely many solutions. So Part B is asking why did we choose those answers? If two lines have the same slope, why could there be no solution or infinitely many solutions? Well, lines with the same slope could have different y-intercepts, which would make them parallel lines. Because parallel lines never intersect, there would be no common point of intersection on the two lines, and therefore there would be no solution to the system of equations. That's why we chose no solution. The second option, we chose infinitely many solution because lines with the same slope could have the same y-intercept, which would make them be the same line. And because lines that are the same intersect at all possible points, there would be infinitely many common points of intersection on the lines and therefore infinitely many solutions to the system of equations. Now consider this. Suppose you are walking to school. Your friend is 5 blocks ahead of you. You can walk 2 blocks per minute and your friend can walk 1 block per minute. How many minutes will it take for you to catch up with your friend? So think about how can you answer this question. What information is given? What tools do you know that can help you answer the question? And how maybe does this relate to systems? Well, first let's make a table to represent the problem. So we have the first column in our table will be the time in minutes, since you are taking a certain amount of minutes to go a certain amount of blocks, and so is your friend. So then the second column would be your friend's distance from your start, which is in blocks, and then your distance from your start when you start walking in blocks. And then we can compare. Remember, you have the information that you walk 2 blocks per minute and your friend can walk 1 block per minute. So you want to think at time 0, where would you be starting? How many blocks would you have walked? And then after 1 minute, after 2 minutes, after 3 minutes, after 4 minutes, after 5 minutes to complete the table. So again, your friend is 5 blocks from your start and you're 0 blocks at 0 time. And then your friend is walking 1 block per minute. So after 1 minute, you would add 1 to 5 to get 6. Then you would add 1 to 6 to get 7, add 1 to get 8, add 1 to get 9, and add 1 to get 10. Now you're starting at 0 blocks from your start, but then you can walk 2 blocks per minute. So you would add 2 to 0 to get 2, 2 to 2 to get 4, 2 to 4 to get 6, then add 2 to get 8, and add 2 more blocks to get 10. So if we then look at this on a graph, if we plot these ordered pairs on a graph, if we think of looking at the time as our x-axis and then the number of blocks on our y-axis, we would get 2 different points. We would get, for your friend's distance, that's what's graphed in green. You would have 0, 5, 1, 6, 2, 7, 3, 8, 4, 9, 5, 10. That's the green line on the graph. And then the orange line is then your distance. You would have 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, 5, 10. And you can see graphically what that looks like. Again, comparing the time in minutes to the distance in blocks of you walking and then your friend walking. So you can see that the point where the lines intersect is the solution to this system. It's the solution to the time versus you and your friend walking in blocks. So that point is 510. So 510 is the solution to that system, meaning it's also the solution to your answer the solution to your question before. Right, in the context of this problem, this means that after 5 minutes, you will meet your friend at block 10 because that's when your blocks are the same at the same time. So you can use a system and graphing a system to answer that question and find the solution to that system, that point of intersection. Solve this system of equations graphically. We have the system y equals 2x minus 1 and y equals x plus 1. To solve the system graphically, we'll graph each line, or each equation of the line, and then we'll see where those two lines intersect. That would be our solution. This system will be easy to graph because both of these equations are in slope-intercept form. The first equation, y equals 2x minus 1, has a y-intercept of -1 and a slope of 2, where we go up to right 1, up to right 1, up to right 1, up to right 1 to graph our line, or down to left 1, down to left 1 to create our line. The second equation is y equals x plus 1, so the y-intercept is 0, 1, and we have a slope of 1, so we're going up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, down 1, left 1 to create that line. So there's our two lines. Again, the system solution will be where they intersect. These two lines do intersect. We had different slopes and different y-intercepts, and we can see that point of intersection to be the solution. It is going to be the point 2, 3. Let's do another example. Here we have solved the systems of equations graphically. We have the equations y equals -3x and y equals x minus 4. Again, this system is nice and easy to graph because both equations are written in slope-intercept form. The first equation, y equals -3x, has a y-intercept of 0, 0, and then a slope of -3. So we would go down 3, right 1, down 3, right 1, down 3, right 1, or up 3, left 1, up 3, left 1, up 3, left 1 to graph the line. The second equation, y equals x minus 4, that has a y-intercept of 0, -4, and then a slope of 1. So up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, down 1, left 1 to create our line. And the solution will be where those two lines intersect. It'll be the point of intersection here, making the solution 1, -3. Now here, we're already given the graph, and we have the question, what is the point of intersection? So we have the two equations, and we can just look graphically and see where these two lines are intersecting here. This point of intersection is 1, -4. Now that's what we're seeing visually, but we can be 100% sure. We don't just have to rely on our eyes or graphically. What if we made a mistake graphing? What if we messed up our slope? What if we messed up our y-intercept? There is a way to check. We can take that ordered pair we just found. Remember, we found the ordered pair 1, -4. And we can substitute it into the equations to prove that it is a solution for both lines. We have an x value of 1 and a y value of -4. So that's what we're going to substitute into the first equation. Y equals -3x minus 1. So y equals -4 and x equals 1. That will give us -4 equals -3 times 1 minus 1, which -3 times 1 is -3, and -3 minus 1 is -4. So that ordered pair, when substituted into the first equation in the system, provides a true statement, so it's a solution to that equation. Now let's test it in the second equation in the system. We have y equals 4x minus 8, so y equals -4 and x equals 1. So that gives us -4 equals 4 times 1 minus 8. 4 times 1 is 4, and 4 minus 8 is -4. So again, now it's also true, that point in the second equation. So we can always check our work when finding our solution to our system by substituting it into the two equations and seeing if it provides true statements.